Welcome, Mr. Tang.
Yes, thank you, Ms. Hao, and thanks to for all the people here. So today I will try to explain very briefly into the topic of satellite communication, and especially direct satellite to phone communication. Okay. So I believe all of you may already have some background knowledge, and I still would like to repeat it briefly. Satellite communication, some characteristics of satellite communication now. Since this is increasingly becomes a hot topic and a very hot trend for phones, especially flagship phones, to be equipped with satellite communication capabilities. Now we have some facts, very fundamental facts about satellite communication. One is satellite communication usually historically are now still being used for large open area coverage, especially some of the areas limited by terrain. Also maritime communication can only be achieved by satellite communication. So and also it's normally satellite communication has quite a limited system capacity compared to terrestrial communication systems because we have a limited number of satellites on the orbit. So the system capacity can be roughly determined by several factors, including an allocated spectrum. In the morning, I think some colleagues and Mr. Michael Chang talked about this spectrum topic, and also number of satellites on the orbit, and onboard processing power, and also feeder link capacity and other topics, other factors. And now we have normally it can be three kinds of satellite communication, like GEO, MEO, and LEO. And I think the GEO is a geostationary orbit satellite communication, and normally it can cover a very large area. 3 satellites can cover the whole area of the surface of the Earth, in theory. And for LEO system, we normally have hundreds, even thousands of satellites on orbit to provide coverage and as well as a much larger capacity. So now there's a trend coming into shape that convergence of satellite communication and terrestrial communication will provide seamless mobile services to billions of users. Traditionally, this kind of service was only available to business users, to be business kind of usage scenario like logistics, like asset tracking, like emergency. Now we have received the opportunity that this kind of service will be available to billions of normal users, of everyday users, directly on their smartphones. So we can see it in the diagram, in the pictures, like especially in some scenarios like disaster relief. There's the terrestrial network is destroyed or temporarily disabled. The satellite communication will be very useful. And when the system capacity and capability of the terminals are increasing, we can see the applications can also becoming more interesting and attractive from very basic preset message to user-defined message and to voice call and in the future to data services very low throughput and eventually to data services with high throughput. And in that way, normal users and consumers can enjoy their life experience in very remote areas, like in the ship, on a ship, and maybe in the deep of the ocean, and with a very rich multimedia service provided by supported by satellite communication, will be also becoming possible. So since we are a terminal vendor, a UE vendor, we want to discuss some expectations from users on satellite communications. Like from a user perspective, I think normal user cannot distinguish between maybe if satellite communication service is good enough, they cannot distinguish between what kind of services they are being served, like between satellite communication and terrestrial communication services. So we need to ideally we can have a common user profile, like for example one single SIM card provided by the operator, by the carrier. So this SIM card will enable the users to enjoy both terrestrial communication and satellite communication, and to automatic select the technology suitable for their the application scenario. So it's not, it should be a user agnostic. So users do not have to manually select or manually switch from one mode to another. So this is, I think, very ideal scenarios for the user. And also, now we have only very limited user usage application for satellite communication, like emergency predefined service messages. So eventually, I think in the future, which and it is very desired to provide enriched applications for non-terrestrial communication to always improve the quality of service and improve the throughput. Also, maybe I think in the even further future, there could be some kind of roaming of satellite services to improve, harmonize, for example, to harmonize regional global spectrum and arrangement, also regulatory agreements. This is also maybe in the even further ways in the future. Now there are basically two kinds of satellite communication technology being discussed in 3GPP. So one is somehow simpler. We call it transparent payload. So in that way, you can see the base station, Genome B is still on the ground, and the Genome B connects to a gateway, and the gateway connects the satellites with a link we call a feeder link. In that way, the satellite just transparently transmit the contents of the payload without knowing the actual content of the payload. And just the condition is the satellite should be able to support the spectrum used by the smartphone. In that way, the smartphone will be able to directly communicate with satellite. And the other way is the other method is called regenerative payload. In that way, there are base stations or processing powers on board of the satellites, and the core network connect to the satellites equipped with gene processing power also through a feeder link, and the satellite itself can provide signal processing capability and can serve the smartphone directly. And there could be also other features like inter-satellite link, LSL, and normally this kind of satellite will be equipped with a very powerful antenna array, very large antenna array to enable the satellites to pick up the big signal transmitted by smartphone to the satellites, and to provide highly directional beam to a certain area to increase the throughput. So currently, there are already two releases of standards being defined by 3GPP. We can see from the year 2020, there are discussions on NR-NTN. There have been discussions on NR-NTN and IoT NTNs in 3GPP, and we have already defined release 17 and release 18 specifications to serve the very fundamental technical support for transparent payload mode. And now the release 19, the release 19 package was completed in just last December in the 3GPP plenary meetings. Now we have a bunch of enhancement of release 19 technologies, including the downlink coverage enhancement, UR capacity enhancement, and also a very important communication between satellites for regenerative payload, and also that data transforming mobility management to enable a more advanced technology and much richer application scenarios in the future. So there are, from the terminal or UE perspective, there are certainly a batch of complexity and challenges for us to resolve. So we can discuss one by one. The number one is complexity. This is a quite new technology to be supported by smartphones. So compared with traditional dedicated purposed smart satellite terminals, the smartphones are facing a quite fragmented markets. So there are the various kinds of satellite systems, the various kinds of satellite standards, and each one, for many of them, maybe each one will need one dedicated chipset, for example, including the baseband chipset and RF radio frequency chipset to support that specific kind of a satellite communication technology. So that in that way, it is very difficult for the UE to support all kinds of satellite communication system. So and to integrate this function also increase the complexity and also the cost of the terminal. So one integrated or unified solution are highly desired from a UE perspective. The other one is system capacity. Now satellite communication system availability is quite still limited. Especially when large number of users use this kind of communication concurrently. So it is very difficult for the satellites to process maybe 1 million concurrent call, voice call, or data linked simultaneously. It's very difficult. And application-wise, we still need attractive applications to be designed to leverage this advantage of SATCOM. For now, we can see on the media there are certain number of cases for successful emergency rescue mission communicated by a satellite system, satellite communications on the phone. So we don't see too much more richer application available yet. And also service continuity. The last one is now for especially for the LEO system. So the time for the one LEO satellite over in the horizon, all the horizon is quite limited. Since the speed is very fast, and the height of the orbit is limited to several hundred kilometers. So this service continuity, for example, realized by inter-satellite link. So this is very important or critical to everyday usage for the end users. And also for UE, the UE design, RF antenna design could be very complicated. Since the UE may need to track different number, maybe more than one or more than two of LEO satellites moving very fast over the head. So this is one problem to be solved. Okay. So finally, I would like to introduce some progress of OPPO on the satellite communication. So in last May, OPPO completed a laboratory testing and verification of 5G mobile terminals directly connected to satellites. Now cooperating with the CMCC and other industry partners. Yeah. Thanks, CMCC. Yeah. And in this March, maybe in a few days, very short time, the new flagship phone OPPO Find X7 Ultra supporting the satellite communication will be launched. So I think I believe more and more phones, especially in this period, flagship phones will be equipped with satellite communication capabilities. So this as a conclusion. So now satellite communication is quite unique, which has unique advantage, especially to be able to cover a large percentage of Earth's area and population not already covered by terrestrial networks, and to provide valuable communications to consumers worldwide. And also satellite communication now evolving with a very fast pace. I think this is very much desirable for the industry to provide unified solutions, and the terminal side are urged to reduce complexity and cost and better user experience. In this way, I'd like to congratulate the CMI to already have launched the two satellite experimental satellites to have equipped with regenerative payload capabilities. I think recently. I think this is a very good sign for the industry. Thank you very much.